Space is the ultimate destination for a set of tiny satellites that could show engineers new ways to build satellites in the future. But first, the payloads will prove their designs and structures during a projected June 15th launch in California's Mojave Desert. The satellites are 4-inch cubes and weigh less than 3 pounds apiece. In that small area, engineers have tucked everything a spacecraft would need to operate on its own and share what it finds out. The flight is also being watched closely as a model for trying out new or off-the-shelf technologies quickly before putting them in the pipeline for use on NASA's largest launchers.
This is a high-altitude launch at about 20,000 feet. They may go a little bit higher than that. And it's a short duration flight, but it's a little harsher conditions than we may normally see for shock environments. So we're testing all of our systems and all the breakpoints, the things that you would expect to see happen.
There are 4 payloads going up on a small rocket designed specifically to the unique demands of the small satellites, which are commonly called nanosatellites or CubeSats. One, called PhoneSat, was built by NASA's Ames Research Center out of a smartphone. Although earlier models flew in orbit, the designers wanted to try out new things before making another orbital flight. Launching on a small rocket gives them a chance to make a change and evaluate it before putting the payload on a full-up mission. Students from California Polytechnic Institute in San Luis Obispo and Merritt Island High School in Florida teamed up to build the Cal Poly 9 and StangSat. The two measure vibrations and other conditions inside the rocket during launch and share the readings between each other on a Wi-Fi network.
The first benefit that we're getting is an actual flight data collection experiment to see how much it shakes and how hot it gets. So we have an interest in understanding what the true environment is so that we can perhaps relax some of our criteria for our design on our spacecraft, and that might allow them to do more useful things.
Part of it that's really cool is you see all the rockets launching. You just go outside your front door and you see the rockets, but this is hands-on. It's not so foreign because honestly before this I was thinking like rocket scientists, they're so geeky and like they don't know how to talk to you, but they do. And so it's really cool to have that hands-on experience.
The upcoming launch will also test a new CubeSat launcher and carrier that weighs a third of the current model. That means future CubeSat engineers could have more weight for their own designs.
We also are developing a new low-cost deployer for NASA, where we're really trying to bring down the mass of the deployers because for a NASA primary mission, mass is not really an issue. But for these nanosat launch vehicles, it is. So if we can save 2 or 3 kilograms on the deployer itself, that's a tremendous savings.
An experiment from participants in NASA's Rocket University will also evaluate the launch vehicle conditions throughout the flight. Rocket University is a professional program by the agency's engineers to develop technical expertise outside their specialty areas. CubeSat's success at this point could clear the way for more such spacecraft missions that scientists say could have a big impact on how satellites are designed in the future and what kind of stresses they actually face during the climb into space.
A lot of the payloads on this mission are monitoring the launch environments. So they're monitoring pressure, temperature, vibration. And all of that data is extremely valuable to us as the integrators and also to the launch vehicle guys, because that'll give us an idea of what the environments are and how can we isolate those environments for future payloads once we go orbital.
The launch is the second operational flight for the Garvey rocket, a liquid-fueled booster that returns safely to the ground under a parachute to be used again. A safe landing also will allow the CubeSats and research payloads to be evaluated and potentially fly another mission.
The whole goal of this is to mature these technologies in all the different sectors to hopefully one day be able to go orbital with these vehicles and then launch these CubeSats as primary payloads.